You've probably seen those videos, right? On one hand, you've got these robots doing incredible things with surgical precision. And on the other, you see them fail spectacularly at just, picking up a cup. So what gives? What if the problem isn't the robot's hands or its cameras, but its mind? Well, today we're diving into a wild new idea. What if you gave a robot two brains, a planner and a perceiver, and taught them to think at the exact same time? All right, so let's get right to it. What's the fundamental challenge here? I like to call it the clumsy robot problem. See, robots are amazing when they're in a super predictable place, like a factory assembly line. Everything is exactly where it's supposed to be. But our world, our kitchens, our living rooms, they're messy, they're unpredictable, and they're just full of surprises. I mean, think about something as simple as making a cup of coffee. You and we don't even think about it, right? You find the mug, you see the handle, you grab it just so, move it under the machine, hit the button. It's pure muscle memory. But for a robot, every single one of those steps is a massive hurdle, a place where the whole thing could just go completely wrong. And this really gets to the heart of the problem. There's this huge disconnect, this massive gap between two completely different kinds of thinking. On one side, you have the high-level plan, right? The what to do. First this, then that. And on the other side, you have the low-level action, how to do it, actually understanding the physical world in front of you. Getting robots to connect those two, to bridge that gap, it's been one of the biggest challenges in robotics for a long, long time. So to try and fix this, researchers came up with a pretty clever idea. They decided to give robots an inner monologue, a way for the robot to actually think through the problem before it moves a muscle. And honestly, this was a huge leap forward from the old way, which was basically just reacting blindly to whatever its sensors saw. This technique has a name you might have heard before, chain of thought, or COT for short. The AI literally talks itself through the task, step by step. It generates a little plan like, okay, first, I need to pick up that red block, and that thought guides its next action. It's all about getting the robot to think before it acts. But, and there's always a but, isn't there? This created a whole new, unexpected problem. So here's the deal. It turns out this inner monologue came in two flavors. You had the linguistic chain of thought. Let's call this the poet brain. It's amazing with words, logic, and big picture planning. It knows the sequence of things to do. But it's kind of book smart. It's all abstract. It doesn't really see or understand the physical world. Then you have the other flavor, the visual chain of thought, the painter brain. This one is a genius at seeing the world. It understands space, where things are, how they're oriented. It's got the street smarts. But ask it to come up with a multi-step plan, it just completely falls apart. So you were forced into this impossible choice. You could have a robot that was a brilliant planner or a robot that was a brilliant artist, but you could never have both. And that brings us to the big breakthrough. People realized the problem wasn't that the robot was thinking. That was actually a good thing. The real problem was that it was being forced to think in only one way at a time. It had to choose, be the poet or be the painter. So that set up the ultimate challenge, right? What if you didn't have to choose? What if a robot could be both the poet and the painter at the exact same time? How do you get these two very different ways of thinking to work together, in harmony, without messing each other up? Well, the answer was to let them think in parallel. Okay, I know this diagram looks a little intimidating, but trust me, the core idea behind it is actually super simple and really elegant. This is the blueprint for a new model called DualCoT VLA. Now, see that box in the middle, the VLM? Think of that as the robot's central brain. Now, instead of giving it just one command at a time, the system does something really clever. It sends two special prompts simultaneously, a visual one, that's the blue stream, and a language one, the pink stream. This is the secret sauce. It's basically telling the brain, hey, I need you to be a painter and a poet right now at the same time. And all of this parallel thinking happens in one single, super efficient step to produce the final action. So let's break that down a bit. Let's zoom in on those two parallel streams of thought and see what each brain is actually doing. Yeah, this shows it perfectly. On the left, you've got the visual cot. That's our painter brain. It's constantly looking at the world through the robot's camera, figuring out the 3D layout of the room, where everything is in physical space. Now, at the exact same time, over on the right, you've got the linguistic cot, our poet brain. It's creating that logical, step-by-step plan. It's keeping track of the goal, labeling objects with words, and figuring out what the next move should be. And the magic word here is simultaneously. They are both happening at once. And here's why going parallel is such a game changer. The older models, they had to think one word at a time. It's a process called autoregressive reasoning, and man, was it slow. But it wasn't just slow, it was also super fragile. If it made one tiny mistake early in its thought process, the whole thing would just collapse. It was like a line of dominoes, one wrong move and it's all over. By thinking with both brains at once, this new model just completely sidesteps that whole problem, which makes it way, way faster and so much more reliable.
All right, so the theory is beautiful, right? You get the poet and the painter working together in perfect harmony. But does it actually work? Does it hold up in the real world? Let's take a look at the data, because honestly, the results are pretty mind-blowing.
First up, let's talk success rate. How often does it actually get the job done on really complex tasks? Now, the previous best model was already, crazy good. It succeeded 97.9% of the time. That's a high bar. But look at this. DualCoT VLA bumps that up to 98.8%. That might not sound like a huge leap, but at this level, it's a new state of the art. It's just plain better at succeeding. But this is the chart that really changes the whole game. Forget success rate for a second. Let's talk about speed. The old thinking robots, the ones that use that slow step-by-step process, they took over 3,000 milliseconds. That's more than 3 seconds just to decide what to do next. In the real world, that is an eternity. Now, the action-only robots were fast, but they were kind of dumb. But look at DualCoT VLA. 83 milliseconds. It's practically the same speed as the dumb robot. It's thinking like a genius, but acting on instinct. We're not talking a little bit faster here. We are talking over 30 times faster. The choice you used to have to make between being smart or being fast, it's gone. So this isn't just another small step forward. This idea of parallel reasoning, it represents a fundamental shift in how we build machines that can actually think and act in our messy physical world. So let's just quickly recap the whole story here. We started with these clumsy robots that had this disconnect between planning and acting. The first attempt to fix this chain of thought was clever, but it created this split personality, the poet or the painter. You couldn't be both. The big breakthrough, DualCoT VLA, was all about fusing those two brains together, letting them reason in parallel. And the results? A robot that's smarter, more successful, and doesn't have that crippling speed penalty. You finally get the best of both worlds. It's smart and it's fast. By finally solving this poet versus painter problem, we've taken down one of the biggest roadblocks standing in the way of truly general-purpose robots. Robots that can navigate the chaos of our everyday lives. And that leaves us with a really exciting question to think about. Now that we've taught them to think and act in a way that's so much closer to how we do, what should we ask them to do next?